I hope everyone got their pastries and coffee, et cetera, this morning. And I know this talk is right before lunch, so hopefully I can not take too much of our time so that we can go and eat. But of course, we have important things to talk about today. We're talking about merged PRs, an untapped resource for practice and exploration. I gave this talk another title, actually. It's Merged PRs. Let's talk about debugging and then practice debugging and also build confidence by diving into the Rails code base, which hopefully helps us become better Rails debuggers and developers. Because that is what I hope we get out of this today. Here's the plan. We're going to start by walking through some theory behind debugging, and we're going to take a look at the role that it plays in the industry, and we're going to identify opportunities for improving debugging competency. After that, we'll look at this idea of using merged PRs to improve our competency through practice and exploration. So that's it, just those 2 steps. Before we jump in, a little bit about me. I work at a company called Zendesk, as was said, with thousands of other engineers working on Ruby and Rails, and I work on a core Ruby engineering team, and I see our job as being, as corralling the use and abuse of Ruby and Rails at Zendesk. And I will say it's different than the Rails core team or the Ruby core team. I'm not on those teams. This is specific to Zendesk. The last thing I did want to mention is that I'm a community taught developer, and I'm endlessly curious. And that ties into this talk a bit. So we'll begin by talking about the theory behind debugging. What is it, and what does it mean to the industry? The ISO, IEC, and IEEE, 3 really important organizations for standards, they have a joint definition of debugging, which is to detect, locate, and correct faults in computer software. And for the sake of this talk, let's just say that faults occur when software displays unexpected behavior. And so our working definition is this. Debugging is the process of detecting, locating, and correcting unintended behavior in software systems. So with this definition, I would like to conduct a small survey. I would like you to raise your hand depending on what percentage of your time you believe you spend on debugging. And I'm asking about coding time, which is different than meetings and the other things that take up a lot of our time. So I'd like you to raise your hand if you believe you spend between 0 and 25% of your time on debugging tasks. All right, and you can take a look around. You can see I'm seeing not so many people, maybe 20 people or so. Next, raise your hand if you think you spend between 25 and 50% of your time debugging. Okay, quite a few more. I would say 1 in 3, 1 in every 2 people. Next, between 50 and 75%. Okay, back down to a few people. And lastly, if you spend the overwhelming majority of your time debugging, 75 to 100%. All right, I'm so sorry. No, that sounds great. There's about 3 people. Okay, so it looked like the majority was between 25 and 50%. That tracks, at least from what I understand. But is anybody surprised by that number, 25, 50%? Or does that sound about what we expected? Okay, a few people. Well, if we summarize the various studies across the past few decades, we find that the average software developer spends between 35 and 50 and upwards of 70% of their time on debugging. And researchers have used both qualitative methods like conducting surveys or conducting interviews, but they've also used quantitative methods like looking at IDE analytic data, for example. And broadly speaking, there's consensus that engineers spend generally a majority of their time on debugging. Not only do engineers spend a lot of time debugging, companies spend a lot of money on debugging. A 2022 report from the Consortium for Information and Software Quality on the cost of poor software quality in the US concluded that the cost of finding and fixing deficiencies is the largest single expense element in the software development lifecycle. Almost 50 cents out of every dollar will go to finding and fixing bugs. And they specify that these costs go towards finding and fixing bugs. This does not include the other costs of damages or reputation lost that can be associated with software bugs. And this study really got me thinking, because I'm wondering what the ratio of construction and correction is in other industries. I didn't go down this rabbit hole, but if we just imagine 50 cents out of every dollar going towards correction in, let's say, the construction industry, that would seem really crazy and inefficient, I think. But I think there's something to be said about the way that we develop software. We've moved towards iteration and away from design by committee that other industries like construction still use and need. And of course, it depends on the software that's being written. A firmware for an open heart surgery robot has a very different risk profile than the web apps that most Rails developers work on. But what other industries call rework and waste, we just call debugging and iterating and being agile. This is one of my favorite quotes from some of the earliest literature on debugging. Everyone knows that debugging is twice as hard as writing a program in the first place. So if you're as clever as you can be when you write it, how will you ever debug it? Debugging is a costly yet vital part of software developers. So as practitioners, I think it's essential that we continue to invest in our debugging capabilities in order to become more confident, competent, and efficient. And since we spend so much time, effort, and money on debugging, let's take a second to go beyond the definition and look at what it means to be good at debugging. And although the practice of debugging can vary widely depending on the language, the environment, or the domain, there are a common set of behaviors that are exhibited by proficient debuggers. And I like to call them the debugging competencies. And they are identifying problems, reproducing issues, applying a systematic approach, comprehending code, proficiently using debugging tools, communicating effectively, and learning from experience. So the first one, identifying problems, is described as the ability to recognize and isolate issues in code based on error messages, unexpected behavior, or user reports. And an example of this is if our app crashes, are we able to determine the immediate cause by observing what state the application was in, reading error messages, stack traces, or analyzing crash reports? It's the difference between saying, my app is broken, and when I enter text instead of an integer into the input field, the input parser raises an exception, for example. The next one is reproducing issues. It's the ability to consistently and accurately reproduce bugs in order to understand their root cause. And so once we're able to isolate an error to a particular line of code or an application state, we want to be able to reproduce that error in an environment that we control, like a test environment or a staging environment. And this allows us to test our hypotheses while controlling the other variables. Next is applying a systematic approach. It's about employing a structured, methodical process while debugging. And one of the most cited debugging methodologies is from the book Why Programs Fail by Andreas Zeller. And in it, he walks through what he calls scientific debugging, which is a modified form of the scientific method. And we'll talk a little bit about that later as well. The next one is comprehending code. And this is about the ability to read and understand code quickly and having a strong mental model of the system. And Rails conventions are really good for this because if we find ourselves debugging an unfamiliar Rails code base, but it follows Rails conventions, we can often find ourselves making progress more quickly compared to working in an app that doesn't follow conventions. Number 5 is proficient use of debugging tools, and it's about the effective use of techniques like the ones listed here. Interestingly, studies show that being confident with just a few even less advanced debugging methodologies like prints or puts debugging it can often be sufficient for most problems. User friendliness, or the lack thereof, is the common barrier for adopting more advanced tools, or what are called more advanced tools. The next is communicating effectively, which is about describing the problem, the reproduction steps, and the solution to others. And we see this manifested in bug reports, PR descriptions, as well as in writing tests. And the last one, we have learning from experience, or continuously improving our debugging skills by learning from past experiences, keeping up to date with best practices, and updating our mental models. And we also see this when we take a fix for a bug in our application and maybe submit that upstream. That demonstrates taking a localized fix and turning it into a global solution. Now, if we just take a step back from the literal act or literal definition of debugging, we can see that most of these competencies are relevant to software construction, not just debugging. And this is because debugging skills inherently involve understanding the code, its structure, and its functionality, which are essential for software development and general programming. And this is another reason why debugging is important to our work as developers, and why I'm so excited about debugging education. Not only is debugging costly in terms of time and effort and literal dollars, becoming better debuggers means becoming better developers. And so that begs the question, how do developers become better debuggers? How do developers, that's a fun one. How do developers become better debuggers? And the short answer is by accident. The vast majority of developers do not learn or train debugging skills in the way that they learn algorithms or design patterns, for example. Instead, developers most often learn on their own through trial and error, community resources, or they're informally mentored. And given the omnipresence of debugging within the industry, this has been studied time and time again from as way back as the 1970s. And almost every paper I reviewed related debugging, was related to debugging, emphasized that we should include debugging course material in our university curriculum, or otherwise have structured learning around debugging. And yet, as early as 2017, a field study and survey published in the Software Quality Journal concluded with this. When we asked developers where their knowledge of debugging comes from, many said, big chunks are self-taught, and I picked up various bits and pieces on the internet. That mirrors my experience. Those who did report having had some form of debugging education, they did not respond significantly differently to other questions related to debugging. And on the surface, this can look like a problem. Debugging is a very important skill in our industry, and yet it's rarely formally taught. But I think the counterfactual is a little bit more interesting. If formal education was the best way to teach and learn debugging, then perhaps we would see more of it by now. But despite years and years of research, we don't see it. And so I'd like to posit that it isn't more formal education that we need, but instead better, if not just more, intentional practice and mentorship that provide real-world, hands-on debugging experience. And just to recap why I think becoming more competent with debugging is so important in the first place, debugging takes time. Most of us spend a significant portion of our time and effort and money on debugging rather than constructing code. Debugging costs money. Finding and fixing bugs is the single largest expense in the software development lifecycle. I still find that so surprising. Debugging is development. Competency in debugging correlates to competency in programming. And lastly, debugging isn't taught. And the majority of us have had no form of education in debugging, and those of us who have may not actually be better off for it. I'm excited because the Ruby and Rails communities have the opportunity to lead the industry with our debugging expertise, just as we've done with our testing mastery. And yeah, I just quoted myself. Okay, Thomas, we got you. So let's take this big idea, this kind of pompous idea and see what it looks like in practice. That brings us to our next section, strengthening core competencies with insights from the community. In order to bring intentionality to our debugging practice, I'm proposing to you an exercise that uses merged PRs for practice and exploration. Using merged PRs to lead debugging practice offers us the opportunity to get immediate feedback within a low-stakes environment. And these real-world examples from the Rails code base invite us to take a deeper look into the framework than we otherwise might. And what makes this resource so valuable is that it already exists. There is no cost involved in taking advantage of what's already there. The artifacts of development that are left behind can be used for either self-directed study or through guided mentorship. So here's how it works. We start by setting up our development environment. Then we find a good candidate PR, one that's a bug fix. It has a clear description of the bug and perhaps one that has a relatively small number of lines changed. The key here is to not read the code of the PR. We want to approach this with only the description of the bug in mind so that we can put our debugging skills into practice without being influenced by what we know worked. Next, we start the actual debugging process from puts and breakpoints to benchmarking and tests. And then finally, once we feel like we have a solution or otherwise get stuck, and that's also okay, then and only then do we take a look at the patch and the code and try to compare our solution to what was ultimately merged. So with that, let's go through these a little bit more deeply one at a time. Setting up our lab. A quick meta note, I'm gonna go through this section relatively quickly because I'm assuming we all kind of have Ruby and Rails development environments set up. Maybe not to work on the actual Rails framework, but we have Ruby installed and that sort of thing. And then also setting up your development environment for this exercise is the exact same way as you would set up your environment to work on Rails. And that's covered in the contribution guides within the Rails guides, so certainly check those out. So at a high level, there are two different approaches for setting up the environment for this exercise. And in both cases, it begins by forking Rails. So if you haven't forked Rails, you can go ahead and just click fork on GitHub and you have the code right there. The two approaches after that are either to clone the code locally and build a new Rails app using the dev flag, and I'll talk about what that is if you're not familiar, or we can use GitHub code spaces to write and run tests and take advantage of the bug report templates. And both of these are also covered in the Rails guides. But with that said, seeing that we're practicing using bugs that are already fixed in main, we need to be sure that we're working with code as it existed before the PR was merged. And so this is how we would do that. We want to use the SHA of the merge commit, which we can find at the bottom of the pull request once it's been merged. And we want to branch off of that merge commit's parent. And we do that by using this caret symbol at the end of the SHA. And once we branched off the parent commit, we then have the code as it existed before the fix was merged. And to build an app from this code, we run bundle install, and then we run Rails new with the dev flag. And what this will do was we'll update our gem file by adding the path option to the Rails gem declaration, and it will point to our current directory. So therefore, we want to run Rails new with the dev flag within our Rails directory where we cloned our fork, and then we pass in a relative path to Rails new. So here I'm just going up one directory and building a new Rails app. After everything's finished installing and bundling, then we have an empty app as it would have existed before the bug was fixed. And then now we can build a Rails app like we normally would and start replicating the bug by building up parts of the application that are relevant to the issue. The other option is to use GitHub code spaces. This allows us to develop directly in the browser or through VS Code. We can run the Rails tests, which is great, and we can avoid having to manage all the dependencies of Rails or use VirtualBox or any of that kind of stuff. To create a GitHub code space, you just go to github.com/codespaces, you click create new code space, you follow the instructions, and then you'll have a VS Code instance initialized right in the browser. And if you prefer to work locally instead, you can use the Remote Explorer extension, which is built by GitHub. And either way, after you have the code space, you can check out the parent commit of the merge commits, the merge commit like we did before and run bundle install just like we did before. And now we can run our tests and poke around. After we set up our environment, then comes finding a candidate PR. This is a PR that we want to use for practice. And I will say I found this part the most difficult at first, and it was quite overwhelming. There are thousands of PRs, and I felt like I didn't know where to begin. It just didn't seem possible that I could pop open a PR of Rails and just understand what was going on. But I did find that there are a few ways to go about looking for well-scoped PRs that are isolated enough to make practice easier. And so first is to be sure that we're looking for bug fixes. Luckily, not all code that goes into Rails is a bug fix. There are also new features, there are documentation updates, and that sort of things. The Rails repo doesn't use any labels to specify bug fix PRs, so we'll just have to do a text search. Things like bug fix, or fixes, or regression, and sift through after that. The next is for looking at linked issues, and this is really nice because I like to imagine, looking at the linked issue, that that's what the PR author must have had when they begun their work. So it really helps me go into their shoes and try to solve this issue on my own. Similarly, there's no way to distinctly filter for linked issues in PRs, but in the UI, there's a little symbol that specifies that there's a linked issue when you're looking at the list of PRs. The next is that you can focus in on a particular component. As Eileen mentioned earlier, there are 12 components in Rails, and each of them have their own label in the Rails repo of the PR. So if there's a component that you're particularly interested in exploring, or there's a component that you're not familiar with, that's most of them for me, you can filter specifically for a component. I tend to like active record myself. Next, we want to narrow down to PRs that have a relatively small number of code changes. And I've found like plus or minus only about 100 lines changed. I think lines changed maps pretty well to complexity, and lower complexity is just easier to practice. And again, there's no way to filter for this in the UI, but perhaps the GitHub API might offer better options. I haven't quite tinkered with it yet to figure that out. Another thing is the discussions. That's the number of kind of comments on the PR. Sometimes PRs with a lot of discussions can be really insightful, but what I found was the PRs with the most discussions tended to be controversial or required a lot of rework. So even though they're really fun to read and they offer a lot of insight, they don't necessarily make for good practice. So PRs with shorter discussions seemed best. And then lastly, we want to be sure that we're looking at PRs that were merged and not simply closed. The default filter for PRs in the UI is open or is closed, but confusingly is closed also returns merged PRs. So you just want to be sure that we're looking for is merged. So admittedly, this part is quite a manual process, but it doesn't come without benefits. You're forced to read a lot of PRs. It's never a waste, honestly, to examine merged PRs, even if they don't end up being good for practice. With that said, I'm planning to share a long list of PRs that I've found to be good candidates, as well as the slides for this talk after the conference. So you can look out for those if maybe reading through a bunch of PRs doesn't sound that exciting. With that said, I do want to just quickly share 3 PRs that I think make really good examples. This first one is fix auto increment on primary key for MySQL. This issue has little conversation. It has a clear description of the problem. It has net 11 lines changed, so it's relatively small. And it was recently merged. And I think working on recently merged PRs, or not working on them, but using them for practice is quite good because the code that you're ultimately looking at while you're debugging is perhaps more relevant to you. The next PR is this one, fix add foreign key with if not exists, referencing the same table with but via different columns. This one I found really fun because it has no conversation. It also only has 11 lines of code, but it has the linked issue that we were talking about earlier. And this linked issue is really well written and lays out some reproduction steps. So it really, when I practiced with this one, I could really sit in the PR author's shoes and try to see if I could maybe tackle an issue myself. And the last one I want to share is add support for unique constraints, PostgreSQL only. This one has a fair bit of conversation. 531 netlines changed. It has a great description. It's much longer than the screenshot here. And it was also merged quite recently. However, with a PR this large, I just felt like it was a little too much work for this kind of exercise. I think it's really good to have this exercise kind of feel like a crossword puzzle or maybe a game of chess, but it certainly shouldn't feel like a week of work, and that's what I felt diving into this one. So once our environment is set up and we found a PR to practice with, it's time to get down to practice. This next section is a bit of a lightning round of debugging tools and techniques that I'm currently practicing. It's not exhaustive, and I might go rather quick, but I wanted to kind of share a high-level catalog just to give a sense of how much there is to kind of play and practice with. And a small warning, I am going to ask for audience participation. At the end of this list, I would love if you have a tool that you find interesting to use or a technique that you think is really fun, then I'm going to ask you to share it. So you can think about that as we're going through these. All right, here we go. The first one, of course, it's our favorite. It's puts debugging. It's widely used and often is enough to solve the problem. So if you stop here, you're sometimes pretty good. Similarly, Rails has a built-in logger. You might be familiar with this. You can do things like change the log level. You can add custom log messages, and you can log to different files, which is often really useful. In debugging, we often just log to standard out. And sometimes there are logs that don't go to standard out that we do want to send to standard out when we're debugging. The next one's a technique. It's called scientific debugging. It's the one I mentioned earlier by Andreas Zeller in his book, How Programs Fail. And the idea here is to borrow from the scientific method. His methodology involves observing failure, inventing hypotheses, making predictions based on those hypotheses, testing them by using experiments and observations, and then repeating until the defect is resolved. And he also advocates for keeping a debugging journal. The next is another technique. It's called desk checking. It just means read the code and read the docs, but I thought it had a really cool name. There's also using tests. Yes, tests aren't just for kind of testing for regressions or validating features, but also to help us validate that a bug is fixed. You won't often run all the Rails tests, but there are ways to run specific files, specific lines, specific tests, and that's all covered in the Rails guides as well. There's also the bug report and benchmark templates. These are directly in the Rails codebase. So if you forked Rails, you have these. And they're isolated templates that allow you to run with a minimum set of dependencies. And they're really good, especially when you're opening a bug report, but also when you're debugging, because you can quickly validate that a bug exists and you can quickly reproduce the issue. Similarly, with the benchmark template, it lets us analyze our code's performance and check for any regressions. The next one is Ruby debug, also known as RDBG. It's the default debugging library now, and it allows us to interactively debug our code. We can set breakpoints, we can step through it. Pry and bybug offer very similar features. And there's also the RDBG VS Code extension, and this uses remote debugging. And Justin Searles created a really good video on the Test Double blog about how to get this set up. And it allows you to use the debugging UI built into VS Code while debugging Ruby and Rails. There's also the web console. So this is built into Rails. It allows you to execute arbitrary Ruby directly in the browser, given a certain state of your application. All you need to do to set it up is to install the web console gem. There's bundle open, if you're not familiar. This allows you to open up a gem source code without needing to clone it. It will open within your default editor, and there you can add breakpoints and you can modify the code just as you would your application code. There's git bisect. This is a tool that lets us navigate the git history to find when a certain bug was maybe committed to the code base. There's source location and caller. Source location was mentioned by Eileen earlier. Source location is a method on method that returns the file name and line number where the method's defined, and kernel caller, it returns an array that has the line number, method name, and stack trace. of the current stack frame. And you can use these to figure out where your code's executed from and where it's defined. We also have parser and ripper, and this is the last one I want to mention. There's an asterisk here because I haven't quite found a way to use this for Rails debugging. But if you're not familiar with it, it allows us to interact directly with the abstract syntax tree of Ruby as it's being parsed. So it's good for implementing like code tools or any kind of like automation. So now just a bit of audience participation. Does anyone here have a tool or a technique that I didn't mention that they really would like to share? Yeah, right here. Flame graphs. Great, yeah, so these will allow you in a, yeah, not so much Ripper, but it really allows you to see the execution stack and where your code is taking a certain amount of time. There's one back here. Pry rescue. Yeah. Great, so we have AppMap and StackProf, and great. If there's any others, the hallway track is a great place to share those. Because I do want to, yeah, let's just keep moving. But yeah, there are tons of tools, and I'm certainly not familiar with all of them. And when you're debugging for work, it's usually like the last time you want to try something new. So that's why this exercise I find is really good for experimenting with new tools that you otherwise might not get to use. I'll just cover the last section here quickly. It's about evaluating evaluating your solution. Now that you've got your environment set up and you've went for it, you've debugged it, and you come up with a solution, what do you do next? Oh, sorry. There we go. We're back to the competencies. You can evaluate your code just like you would a PR, but again, that feels like work. If you're just doing a code review and you're checking for correctness, that is important. We do want our code to work. But really, this exercise is about improving our competencies. So I like to use these competencies to kind of reflect on what it is that I learned. And the other thing is to make sure that you have fun, because again, it should not feel like work. This is just an exercise, it's low stakes, and it's about learning and growing. There's always some sort of intangible takeaway that I have when I do this exercise, and it really doesn't feel necessary to do like a real proper code review. As we wrap up, I just want to mention 3 quick things. The first one is that I have not contributed to Rails. I'm just sitting here on the sidelines poking at the artifacts that are there. And I think that's because I really like education, I like growing, and I do want to contribute to Rails one day. And this might be a good way to kind of be comfortable with that, but I am not a Rails contributor, so I certainly can't speak with authority there. There are office hours from the Rails core team during the RailsConf, and I do recommend checking that out if you are interested in contributing to Rails. And the other thing is that analyzing someone's past work is not an opportunity to use hindsight to be very critical of their work. It's important to remember that they're the ones delivering the code, and we're the ones sitting back pretending to be them. So make sure that you practice empathy when you're reviewing historical code. So we began by talking about the theory of debugging, what it means to the software industry. We looked at how much it costs us in terms of time, effort, and money. We defined some competencies. We realized there was no formal education, but that we could define some competencies to guide our own growth and maybe to help others grow as well. And then we used this exercise, which is setting up your environment, finding a merged PR, doing the debugging work, and then evaluating your solution. And so that brings us to the end. That's the exercise. It's essentially just to rewind time, debug Rails using the plethora of tools that we've talked about, and the techniques, and to employ this self-directed exercise to explore, become familiar with Rails, become familiar with debugging tools, and do it in a way that's low stakes when you're not responsible for delivering code on a deadline. So that's it. Thank you, everyone.